So let's now proceed to the last part of sample problem number 1. So we are asked here how much more of the field is needed if you're given a different wet bulb temperature that is equal to 78 degrees Fahrenheit and a value of the approach that is equal to 7 degrees Fahrenheit. So from this given, we can get the value of HV1. HV1 is equal to 34 BTU per pound. And from the value of the approach, we could get the value of TL2. TL2 is equal to 85 degrees Fahrenheit. We get this from approach that is equal to TL2 minus the wet bulb temperature. And then from A, we have the values for TL1, which is equal to 102 degrees Fahrenheit. And we have the value for the range that is equal to 17 degrees Fahrenheit. So delta HV also from A is equal to 22.5622 BTU per pound. At the top of the tower, from delta HV, let us get HV2. Delta HV. Okay. So delta HV is equal to HV2 minus HV1. So, since we're already given with delta HV that is equal to 22.5622 BTU per pound from A and HV1 is 34, we could get the value of HV2 that is equal to 56.5622 BTU per pound. Okay, so H star L1 minus HV2 equal to 68 minus the computed value of HV2, 56.5622, and we'll get an answer that is equal to 11.4378 BTU per pound. Okay. So this is for at the top of the tower. So at the bottom of the tower, let me just erase this. Okay. At the bottom of the tower, we need this formula. HL2 is already given from the previous part of sample problem number 1, which is equal to 42 minus 34 from this, and that is equal to 8 BTU per pound. So to get H star minus H for the liquid, let's just get the average plus 8 divided by 2. And from this, we could get an answer that is equal to 9.7189 BTU per pound. So, to to get the value of n, which is the number of transfer units, we use this formula. So, and since we are already given with the value of delta HV, that is equal to 22.5622, and the value of this one equal to 9.7189, we could get the value of n that is equal to 2.3215. And using n and the initial height that we have a while ago, that we have computed before, we could get the value of field, the height of field, because h is equal to field over n. Therefore, field is equal to h times n. H is equal to 1.6912 multiplied with the value of n, that is equal to 2.3215. The answer would be 3.9261. Since 3 feet is already available for us, approximately an additional foot of fill is needed. So that's the answer for the last part of sample problem number 1, that we need an additional foot of the fill. So let's now proceed to the second problem. Okay, so the second problem says that for the cooling tower described in sample problem number 1, predict the effect of increasing the air rate by 20% with the same liquid rate and a wet bulb temperature of 75 degrees Fahrenheit. So for the given, for sample problem number 2, we use the same cooling tower description with sample problem number 1. And for the required, we are required to know the effect of increasing air rate by 20% with the same liquid rate with a wet bulb temperature that is equal to 75 degrees Fahrenheit. So there, again the given is the same cooling tower description in sample problem number 1, and for the required we are asked to know the effect of increasing air rate by 20% with the same liquid rate with a wet bulb temperature that is equal to 75 degrees Fahrenheit. As for the solution, our G prime V is equal to 1745.9030 pound per hour feet squared. This is from the previous sample problem, from sample problem number 1. So our new G prime V is equal to 1.2, since it is increased by 20% times the initial 1745.9030. And our new G prime V is equal to 2095.0836 pounds per hour feet squared. Take note that the new operating line has a lower slope, which increases H star minus H of V. If n is about the same, TL1 will decrease to give a lower value of H prime minus HL. For this problem, we need to have a guess value of the range. And our guess range is equal to 19 degrees Fahrenheit. So TL2 could be computed from this, which is equal to 83 degrees Fahrenheit. And H star L2 is equal to 40 BTU per pound. So the value of delta HV is obtainable from using this formula, GL CL delta T all over G prime V. We're already given with GL that is equal to 2000